Number 9. A breakthrough that could change an ordinary human life into an extraordinary life, its secondary effects, and beyond. The AI inventor's partner. What if almost anyone could invent something that changes the world? For most of history, having a world-changing idea was not enough. You also needed knowledge, engineering ability, mathematics, programming, access to laboratories, money, specialized software, people who understood patents, people who understood manufacturing, and often years of education before you could even determine whether your idea was possible. That created an enormous invisible barrier between two groups of people who have ideas, and people who can actually build them. What if that barrier begins to disappear? Imagine an ordinary person sitting at a kitchen table with an idea. They are not an engineer. They cannot write advanced software. They have never designed electronics. They do not understand fluid dynamics, materials, science, robotics, or mechanical tolerances. But they can explain what they are trying to accomplish. They say, "I have an idea for a device that could do this." And their AI answers, "All right, let's find out whether it can work." That could become one of the most democratizing technological breakthroughs in human history. The breakthrough. The breakthrough would not simply be better AI. It would be an integrated AI invention partner, capable of helping a human travel nearly the entire distance from idea, understanding design, simulation, prototype, testing, improvement protection, production. The human would still provide the purpose, the imagination, the judgment, the strange question nobody else thought to ask. But AI could increasingly provide much of the technical machinery needed to explore that idea. An advanced version could say, "Here are 4 possible ways your idea could work." Then, option 1 violates a physical constraint. Option 2 would cost too much. Option 3 is manufacturably, but inefficient. Option 4 is promising. I have generated a preliminary design. Seconds later, the person could be looking at something that previously might have required several engineers and weeks of work. Imagine what one person could eventually do. You describe a machine. AI produces the first engineering model. You ask, "Will it break?" It runs structural simulations. You ask, "Can we make it lighter?" It evaluates alternative materials. You ask, "What happens if this motor fails?" It performs failure analysis. You ask, "Can we make this for $100 instead of $500? It redesigns components around manufacturing cost. You ask, "Has anybody patented something similar?" It helps search and organize the prior art. You ask, "What would I need to build a prototype?" It produces a parts list and development plan. You connect it to increasingly capable fabrication equipment. The design becomes a physical object. You test it. Something goes wrong. You show the AI the failure. It diagnoses the problem. The next version is redesigned, and the cycle begins again. That is a completely different invention process. Why this could turn an ordinary life into an extraordinary one. There may be millions of people alive today carrying useful ideas they cannot develop. A mechanic who has spent 30 years repairing engines may understand a recurring problem better than the engineers who originally designed them. A nurse may notice something inefficient in hospital equipment. A farmer may know exactly what type of inexpensive machine would make a difficult job easier. A fisherman may imagine a better piece of equipment. A parent caring for a disabled child may recognize a need that no major company has addressed. A retiree might finally have time to develop the invention they have thought about for 40 years. Today, many of those ideas end there. Not because the idea was bad, because the person does not possess every technical skill required to turn it into reality. An AI invention partner could change that. The person's greatest asset would no longer necessarily be, "Do I know how to engineer this?" It might become, "Do I understand a problem worth solving?" That is a much larger pool of humanity. And pieces of this are already happening. This is no longer purely hypothetical. Google Research introduced an AI co-scientist in 2025, designed to help researchers generate hypotheses and research proposals. Google DeepMind's Alpha Evolve goes farther in another direction. It uses large language models, together with automated evaluation, to discover and improve algorithms. DeepMind reported that it produced new approaches to mathematical and computational problems and has since been applied across areas including genomics, quantum physics, and computing infrastructure. OpenAI reported in July 2026 that scientists are already using AI coding agents in scientific computing workflows to accelerate software development and research tasks. And the U.S. Patent and Trademark Office has already had to address AI-assisted inventions formally. Its revised November 2025 guidance recognizes that AI can be used as part of the inventive process, while maintaining that inventorship under U.S. patent law belongs to natural persons. Think about what that means. We are already having to write rules for a future in which human imagination plus machine intelligence égale invention. But today's AI is not yet the complete invention partner. This distinction is important. Today's systems can produce impressive ideas, write code, analyze information, help with calculations, generate diagrams, propose experiments, explore alternatives, and increasingly operate software tools. But an AI can also confidently produce something that looks technically convincing and is completely wrong. That is dangerous in engineering. A bridge does not care how persuasive the AI sounded. Neither does a battery, a pressure vessel, a medical device, an aircraft, or a machine spinning at 20,000 revolutions per minute. Physics is the final judge. So the complete breakthrough requires something beyond conversational intelligence. It requires verified intelligence. The missing ingredient, AI, that can prove itself wrong. The truly revolutionary invention AI will not merely say, "Here is my design." It will say, "Here is my design. Here are the assumptions behind it. Here are the simulations. Here are the failure modes. Here are the areas where confidence is low. Here is what must be physically tested before anyone should trust it." That is a much higher standard. The system would need to connect language models to physics simulators, CAD systems, electrical simulators, materials databases, chemistry models, manufacturing tools, cost models, scientific literature, testing equipment, robotics, and eventually automated laboratories. Then AI becomes something different. Not simply a machine that talks about invention, a machine that participates in the engineering loop. Then comes the next leap. The AI laboratory. Picture a small workshop 20 years from now. A person has an idea. AI develops the first design. A robotic fabrication system builds prototype Hashone. Sensors test it. Prototype Hashone fails. AI analyzes the failure. Prototype H2 is automatically modified. It fails differently. Prototype H3 performs better. Prototype Hashone finally meets the target. The human may have started the process with nothing more than, "Could we make something that does this?" That would compress months or years of experimentation into dramatically shorter cycles. And once AI can both design and experimentally verify, invention changes again. Secondary effect. Number 1. The garage inventor returns. During the industrial age, sophisticated invention gradually became increasingly concentrated inside universities, government laboratories, and corporations because equipment and expertise became expensive. AI could reverse part of that trend. The garage inventor could return. Except the garage might contain the intellectual equivalent of an engineering department. One motivated individual could potentially gain access to abilities that once required. A programmer, a mechanical engineer, an electrical engineer, a researcher, a technical writer, a data analyst, and a business advisor. Not perfectly, but enough to make an extraordinary difference. Secondary effect. Number 2. The number of inventions could explode. Today, only a small percentage of ideas ever get seriously investigated. Suppose AI makes early-stage exploration almost free. Then instead of asking, "Can we afford to investigate this idea?" people can ask, "Why not test it?" 999 ideas might fail. The 1,000th might change something important. When experimentation becomes cheaper, civilization can afford to explore far more possibilities. That alone could accelerate technological progress. Secondary effect number 3. Expertise changes. Experts would still matter enormously. perhaps even more than today. But their role may change. Instead of spending large amounts of time performing routine technical work, experts could increasingly supervise AI-generated work, recognize subtle mistakes, define constraints, judge evidence, and attack the hardest unsolved problems. The valuable question becomes less, can you produce this calculation? And increasingly, do you understand whether this calculation makes sense? Knowledge does not disappear. Judgment becomes more valuable. Secondary effect number 4. Education changes. Imagine telling a 12-year-old, invent something. Not, memorize this chapter. Not, repeat this formula. Actually invent something. The student proposes an idea. AI teaches them the physics they need. They design it, simulate it, build it, break it, improve it. Suddenly, education becomes partly about creating things that never existed before. Students could learn science because they need it to solve problems they personally care about. That could be extraordinarily powerful. Secondary effect number 5. Tiny companies become dangerous competitors. A company of 5 people could eventually possess capabilities that once required 50 or 500. That would threaten enormous incumbents. A small team could research a market, design a product, write software, develop prototypes, create marketing, manage documentation, analyze customer feedback, and rapidly redesign the product using AI assistance. Innovation could become harder to monopolize, simply through organizational size. The competitive advantage might shift toward who sees the problem first, and who asks the better question. Secondary effect number 6. Invention becomes global. One of the most important consequences could occur outside wealthy technological centers. A brilliant teenager in a small town would not necessarily need to move to Silicon Valley before exploring an idea. A farmer in the Philippines could work on an agricultural device. A student in Kenya could develop a water system. A mechanic in Brazil could redesign a machine component. A nurse in India could propose a better clinical workflow. If advanced AI tools become inexpensive and broadly accessible, intellectual opportunity could become less dependent on geography. That does not eliminate inequality, but it could reduce one of its oldest forms, lack of access to expertise. And then come the problems. This world would not automatically be wonderful. If AI democratizes beneficial invention, it can also democratize dangerous invention. The same systems capable of helping people design useful technologies could lower barriers to creating hazardous biological, chemical, cyber, or physical systems. So powerful invention, AI would need serious safeguards. There is another problem. Who owns an AI-assisted invention? The United States has already begun addressing that question. Current USPTO guidance treats AI-assisted inventions as potentially patentable while requiring human inventors. But the problem becomes more complicated as AI contributes more. Suppose you describe the problem. AI proposes the mechanism. AI performs the optimization. AI creates the final geometry. Robotic equipment builds it. Who actually invented it? Current law has an answer. Future society may continue arguing about whether that answer remains sufficient. There is an even bigger danger. People could stop understanding what they build. Imagine civilization becoming filled with machines designed largely by AI, whose internal engineering exceeds the understanding of the people using them. That produces an uncomfortable situation. Technology continues advancing while human comprehension falls behind. So the goal should not be to remove humans from invention. It should be to create an extraordinary partnership. Human purpose, human judgment, machine intelligence, machine speed, physical verification. Together. Beyond that, now push this idea farther. Suppose AI becomes capable of discovering things that no individual human would have discovered alone. That is already beginning in constrained domains. AlphaEvolve has demonstrated that AI-guided evolutionary search can discover improved algorithms and mathematical constructions, rather than merely repeating known solutions. Then AI stops being merely a productivity tool. It becomes part of civilization's discovery machinery. Imagine millions of people using AI invention partners. Each person provides different experiences, different frustrations, different local problems, different ideas, different intuition. AI gives each of them access to increasingly powerful technical reasoning. Suddenly, humanity is not relying primarily on several million professional researchers and engineers to search the space of possible inventions. Potentially, billions of human minds can participate. That could create something civilization has never experienced. Mass invention. Not mass production. Mass creation. And beyond even that, eventually AI systems may begin connecting inventions across fields that humans normally keep separate. An idea from biology inspires a new material. The material changes robotics. The robotics technology changes construction. Construction technology changes housing. Housing changes cities. Cities change energy systems. One breakthrough triggers another, and another, and another. The rate of technological progress itself could accelerate. At that point, one of the most valuable abilities a human being possesses may no longer be memorizing what humanity already knows. It may be imagining what does not exist yet. So, how close are we to really making it come true? Here is where number 9 differs dramatically from many futuristic breakthroughs. We are already inside the beginning of it. The question is not whether AI will assist invention. It already does. Google's AI co-scientist is explicitly designed as a scientific collaborator. AlphaEvolve has demonstrated AI-driven discovery of improved algorithms and has expanded into practical, scientific, and computational applications. OpenAI's 2026 scientific computing work describes researchers using AI agents in real technical research workflows. The remaining gap is making this capability reliable, multimodal, physically grounded, inexpensive, and usable by ordinary people without requiring a team of experts constantly checking it. Reality Meter. August 2026. If 100% means, an ordinary person can describe a genuinely new physical invention to AI, and the system can reliably help research it, engineer it, simulate it, verify the physics, build prototypes, test them, redesign failures, navigate manufacturing and intellectual property issues, and bring a safe product close to market. Then I would place us at approximately 35–45%. And that is unusually high for this series. Why? Because several of the hardest intellectual pieces already exist in primitive form. AI can reason with technical information. AI can write substantial software. AI can help explore scientific hypotheses. AI can generate and optimize algorithms. AI can use tools. AI can assist researchers today. What we still lack is a trustworthy end-to-end invention machine. 2026, 2030. The superpowered assistant. This stage is largely arriving now. AI becomes dramatically better at technical research, coding, CAD assistance, simulation setup, component selection, mathematics, documentation, prior art research, prototype planning, and debugging. A skilled human working with AI may increasingly accomplish what previously required a small team. The important word is still skilled. The human must know when the machine is wrong. 2030, 2035. The AI engineering team. This is where things could become much more interesting. Instead of interacting with one general assistant, a person may work with specialized AI agents acting like mechanical engineer, electrical engineer, software engineer, materials specialist, manufacturing engineer, cost analyst, and test engineer. They collaborate automatically. A person's idea moves between them. The human becomes increasingly similar to the chief inventor rather than the person performing every technical task. This looks plausible if current agentic and scientific AI progress continues. But reliability will determine whether it becomes genuinely useful or merely impressive. 2035, 2045. The automated invention loop. This would be the real breakthrough. AI designs, robotic fabrication builds, automated equipment tests, sensors measure. AI learns from the result. The machine redesigns, then builds again. The human supervises the objective. At that point, invention begins moving at machine speed. This already exists in limited forms in automated laboratories and computational optimization. The enormous challenge is generalizing it to the messy physical world. 2045 and beyond. The Personal Innovation Laboratory. Eventually, sophisticated fabrication may shrink enough that an individual or small community has access to something resembling an AI engineering department, plus automated laboratory, plus miniature factory. You provide the problem. The system helps discover the solution. That would be the mature version of #9. And if it becomes inexpensive enough, it would not merely create better inventors. It could create hundreds of millions of new inventors. The part I think matters most. We tend to imagine that AI's greatest effect will be doing things for us. Writing for us. Calculating for us. Programming for us. Organizing for us. But its largest long-term effect might be something else entirely. AI could allow people to create things they could never have created alone. That changes the definition of human capability. A person does not suddenly become an electrical engineer, physicist, programmer, materials scientist, and manufacturing expert. Instead, they gain access to machine partners that can bring pieces of those abilities to them. The ordinary person still provides something incredibly important: the lived experience that recognized the problem in the first place. And that may be the hidden breakthrough. There are 8 billion people experiencing 8 billion different versions of the world. 8 billion sets of frustrations. 8 billion collections of observations. 8 billion opportunities to notice. There has to be a better way to do this. For most of history, almost all of those observations disappeared. #9 asks what happens when they don't. What happens when an ordinary person can say, "I think I have an idea," and instead of the idea dying there, an intelligence beside them answers, "Let's build it." That could turn an ordinary human life into an extraordinary one. But the bigger secondary effect is this: it could turn ordinary humanity into an extraordinary inventive force. And beyond that, the next Thomas Edison, Nikola Tesla, Marie Curie, or Wright brothers may not arrive as a lone genius with every necessary skill. The next great inventor may be someone nobody has heard of, sitting at home, recognizing a problem, working with AI, and creating something the rest of us didn't know we needed, until they built it. Where we stand, unlike biological age control, number 9 is not waiting for one enormous scientific discovery. Its pieces are assembling right now. The biggest remaining obstacles are reliability, physical world verification, autonomous experimentation, access, safety, and keeping the human capable of understanding and judging what the AI creates.